In this video, we're going to talk about differentiation of parametric equations. We're going to be talking about specifically the first derivatives and the second derivatives. We already have examples on the screen, but before I jump into any of them, I'll just write out solution here. And the first question is telling me to differentiate y is equal to cos 2t and x is equal to sine t. Now, I'm asked to look for both the first and second derivative of this question. Now, as I'm giving this question, if you notice, the y is equal to cos 2t and the x is equal to sine t. This simply tells us that the parameter we are dealing with is t, okay? So first of all, the first thing we want to do is to differentiate y with respect to t and x with respect to t. First thing here, I will now say dy over dt is equal to, now cos 2t is a function of a function. So the way we differentiate it will be different. First of all, we differentiate the 2t inside the cos. Differentiating 2t inside the cos gives us 2, then times. We now differentiate the cos 2t in all of its totality. So if we differentiate cos 2t, it becomes minus sine 2t. So that dy over dt is equal to 2 times minus sine 2t is minus 2 sine 2t. Since we found the y dt, next one is find the x dt. So write out the x dt here is equal to dx dt of sine t is cos t. Now, since we've gotten dx dt and dy dt, the next thing we want to do is to find our dy dx, because that's what we're looking for as our derivative. So our dy over dx is equal to dy over the parameter. Now, our parameter is t, so it will be dt times dt over dx. Now, we arrange it like this because you can simply just say dt can cancel out dt here, so that you get back your dy dx from the original form here. Now, if you notice, we're not given dt over dx, but we have dx over dt. Now, to get dx over dt, we can just simply take the inverse of both sides for this equation, so that you have dt over dx is equal to 1 over dx over dt. Now, dx over dt is simply cos t, so this is equal to 1 over cos t. Now, from this point, you have your dt over dx and you have your dy over dt. So you can plug both into this equation to get your dy dx. So that your dy by dx is equal to minus 2 sine 2t times your dt over dx, which is 1 over cos t. So if you do this, if you times this and this, you have this as equal to minus 2 sine 2t times 1 for the numerator divided by, for the denominator, you can consider this as over 1. So that you have 1 times cos t, so we cos t here. So that dy dx of this is minus 2 sine 2t cos t. Once we've gotten to this point, you want to look at what you're given to you that you can simplify them. I want to show you something. Anytime you have a trigonometric identity of sine 2 theta, this can be written as 2 sine theta cos theta. Now, in this case, it's not theta, it is t. So this sine 2t can be written as 2 sine t cos t. So instead of writing side 2t here, you can substitute 2 sine t cos t back to this equation, so that our dy dx is equal to minus 2 times 2 sine t cos t divided by cos t. Now we know that cos t can cancel out cos t here, so that I clean up space, I can say dy over dx is equal to, you have minus 2 times 2 sine t. So minus 2 times 2 sine t is simply minus 4 sine t. So that is dy dx. Now the next thing we are asked to find is the second derivative of the parametric equation. So for the second derivative, I will simply clean up space. But before I clean up space, there is something of note that I want to pick out. The dt over dx. So the t over dx that we got here is 1 over cos t. Now write it here, dt over dx. We will need it later for calculating the second derivative. So I'll clean up space here. Now for the second derivative, I'll simply write out for d square y over dx square, then bracket. So for d square y over dx square, I can simply say d square y over dx square is equal to, now I'll be differentiating this one again, the derivative here again. So I can write it as d over minus 4 sine t over dx. Because this is dy dx, we're differentiating it to then become d square y over dx square. So I'd like you to watch this next step closely. For this here, I can expand it as d over dx, open brackets, minus 4 sine t. Since the parameter is t here, first of all, I can differentiate it with respect to t. Now doing that, it will be d over dt of open brackets minus 4 sine t. Now since I'm differentiating in respect to t, my original point was to get d over dx. So how do I get d over dx? To be times dt. The t will now cancel out with the t in the denominator divided by dx. So this will be my d square y over dx square. Okay. Now if you notice, dt over dx is what we've gotten before, which is this dt over dx. So at this point, we can simply jump into and solve the question equal to, if we differentiate minus 4 times sine t with respect to t, becomes minus 4 cos t times, we already have dt over dx before, which is 1 over cos t. So we have 1 over cos t here. Here we can now say cos t cancels out cos t. So that's d square y over dx square is equal to minus 4 times 1, which is minus 4. So this is the second derivative of the first question here. Now you can pause the video and try to do the second question by yourself. But let me clean up space and let's jump into it. So for the second example, I'll simply write out my solution again because I cleaned it. I would say for the second example, my y value this time is 3 sine theta minus sine cube theta, and then my x is equal to cos cube theta. So the question requires us to find the first derivative and the second derivative. Before you do any of that, the first thing you want to do is find the derivatives with respect to theta. dy by d theta is equal to, if you differentiate 3 sine theta, it gives you 3 cos theta minus, if you differentiate sine cube theta, now sine cube theta can be written as sine theta open bracket cube. To do this, you need to use the chain rule. Now, how do you use the chain rule? First of all, you differentiate what is inside the bracket. So what is inside the bracket is cos theta. So it kind of represents what's inside the bracket as, say, u, and then this whole thing becomes u cube. So it differentiates u cube, it becomes times 3u square. So that this is equal to 3u square times cos theta is 3u square cos theta. And then this is equal to 3. Remember, u was represented as what's inside the bracket. And what's inside the bracket is sine theta. So this is sine square theta cos theta. Now we use this answer and plug it back into this equation here. So this is 3 sine square theta cos theta. Okay, so if we got now dy over d theta, the next is to get our dx over d theta. So our dx over d theta is equal to, so if you want to differentiate this to be the same thing like this, to be cos theta inside the bracket and then cubed outside of it. So first of all, you differentiate the cos theta by itself, it becomes minus sine theta, and then you differentiate the whole brackets. But let's say what's inside bracket is a u, so that is becomes u cube, and then it becomes times 3u square. So that if we do this times 3u square is minus sine theta times 3 cos square theta. So you can just write it as equal to minus 3 sine theta cos square theta. So we use this and plug it back into here. So this becomes minus 3 sine theta cos square theta. So what we did here and here is the chain rule. In case you're not comfortable with it, I'll leave a link to another video here. But let's move on. I'll clean up the space so that we can move on. Now at this point, remember we are looking for dy dx. So dy over dx is equal to, the parameter is theta, so we can say dy over d theta times d theta over dx. Now remember, we do not have d theta over dx, but we have dx over d theta. So to get d theta over dx, we simply take the inverse of dx over d theta. So this is equal to 1 over dx over d theta, which is equal to 1 divided by minus 3 sine theta cos theta. Remember, we often use this when we are dealing with the second derivative. So I'm going to write it out here again. This is d theta over dx is equal to 1 over minus 3 sine theta cos square theta. So this is cos square theta here, and this is cos square theta here. So that from there, I can write my dy dx from this equation is equal to dy over d theta. Now dy over d theta is 3 cos theta minus 3 sine square theta cos theta. So I write it as 3 cos theta minus 3 sine square theta cos theta times my d theta over dx is 1 over minus 3 sine theta cos square theta. So at this point, I can give this a denominator of 1. So I can say dy dx. This will be 3 cos theta minus 3 sine square theta cos theta divided by minus 3 sine theta cos theta. So at this point, you often want to look at if you can simplify your dy dx. You can simplify this by factorizing cos 3 theta from the numerator and cos 3 theta from the denominator. So I'll clean up space before we do that, so that I can say dy over dx is equal to, if I factorize 3 cos theta, this is 3 cos theta here, open brackets. If I factorize 3 cos theta from 3 cos theta, I have 1 here minus. If I have 3 cos theta from 3 sine square theta cos theta, I have sine square theta. And then this is divided by 3 cos square theta cos theta, open bracket. If I factorize 3 cos theta from this, I have minus sine theta cos theta. So that this cancels out this, and I have dy over dx is equal to, now it turns out from trigonometric identity, cos square theta is equal to 1 minus sine square theta. So I'll replace 1 minus sine square theta with cos square theta here. So this becomes cos square theta divided by minus sine theta cos theta. So I can say cos theta here is 1, cos theta here, there's a cos theta left. So that I can say dy dx is minus, because there's a minus still left, cos theta divided by sine theta. Then not to space, I can say dy over dx is equal to minus, now cos theta divided by sine theta is cot theta. So I can write it as cot theta here. So I've succeeded in finding my dy over dx. Now the next one you need to find here is to find d square y over dx square. So to do that, I'll simply write 4 d square y over dx square. Now if you've not done this, you can pause the video and try to do it by yourself. So for d square y over dx square, I can write it as d square y over dx square here is equal to d over dx, open bracket. Now remember, since we are differentiating the dy dx again, this will be my dy dx out. Differentiating again, so it enters here minus cot theta. This by itself can be written as d over dx of minus cot theta. So first of all, I want to differentiate this with respect to theta. So this will be d over minus cot theta divided by d theta first of all, times, now the point is to get d over dx here. So this will be d theta over dx. Okay, now we've got now the theta over dx initially, which is this. So this all means that this is the formula I will use, and I can simply say d over dx of minus cot theta is equal to Now if I translate minus cos theta with respect to theta, it gives me minus cosec square theta times, I'll clean up space because all of this is starting to get rough. The theta over dx is simply 1 over minus 3 sine theta cos square theta. So at this point, I can simply write d square y over dx square, which is still the same thing as d over dx minus cos theta, is equal to 1 over, now cosec theta is simply 1 over sine square theta. And by the way, the minus here cancelled out the minus here. So that this is times 1 over 3 sine theta cos square theta. So if you simplify this, d square y over dx square is equal to 1 over sine square theta times 3 sine theta cos square theta is simply 3 sine cube theta cos square theta. Now I can start to simplify it more than this. I'll leave it at this. That's how to find first and second derivative of parametric equations. If you like the video, leave a thumbs up, share with your friends, and subscribe to the channel. Thank you for watching.